Welcome to the fifth video of Chapter 6, which is Section 5, Prove Triangles Similar by SSS and SAS. As you can probably guess, today we're going to learn two new theorems, SSS and SAS. We've heard these before when we were proving triangles congruent, but today we're going to use these theorems to prove that triangles are similar. So a quick review. Which ways do we know to prove triangles similar? Well, the first theorem that we learned was AA, which was angle-angle. And this theorem said that two triangles are similar if they have two pairs of corresponding angles that are congruent. So that was the first theorem, and the only theorem that we've learned so far. Today we are going to learn SSS and SAS. Now, SSS says two triangles are similar if three pairs of corresponding sides are proportional. So when proving triangles congruent, SSS meant the three sides had to be congruent. SSS for similarity means that the sides have to be proportional. They have to have the same ratio. And then SAS says two triangles are similar if two pairs of corresponding sides are proportional and the included angles are congruent. Okay, so remember that the included angles are the angles in between the two sides, the angles holding together the two sides. And again, congruent, they have the same measure. So I think it's best to just jump in and do a few examples. So let's look at the two examples that we have here. The example on the left, are the triangles similar? If yes, write a similarity statement and state which theorem or postulate you used. Okay, so right now we have one pair of angles congruent and we have two pairs of sides. So initially this looks like it might be SAS. We definitely have the A, we have the angles congruent. Let's see if our sides are proportional. Well, 25 on the first triangle is the smaller side. That's because 35 is bigger. Smaller side on the second triangle is 15. I want to know, is that ratio equal to 35 over 21? 35 is in the first triangle, 21 is in the second triangle. Well, 25 over 15, if I divide both by 5, simplifies to be 5/3. 35 over 21, if I divide both by 7, I get 5/3. So great, my sides are proportional. So this looks like it would be SAS. But there's an issue here. So what's the issue with using SAS? Well, the angles that we are given are not the included angles. These are not the angles holding together the two sides. The included angles would be X and A. If we knew that angles X and A were congruent, then we could use SAS. Here we don't have X and A, so these are not similar. They could be, but we cannot prove them similar. Let's look at the next one. Are the triangles similar? State which, if yes, write a similarity statement and state which theorem or postulate you used. Okay, so I'm looking at triangle 1 on the left and triangle 2 on the right. Well, they both have a right angle, so they both have the A. We just have to check the sides around it. Okay, so this left triangle has sides of 12, 16, and 20. This right triangle has sides of 12, 9, and 15. Let's see if they're proportional. 12 on the first triangle, right here, is the smallest side. Second triangle, the smallest side is 9. I want to know, is that ratio equal to 16 in the first triangle, that's the middle side, that corresponds with 12, the middle side in the second triangle. And then is that ratio equal to 20 is the biggest side, and then 15 is the biggest side? So now I need to simplify. 12 over 9, if I divide both by 3, I get 4 over 3. 16 over 12, if I divide both by 4, I get 4 over 3. 20 over 15, if I divide both by 5, I get 4 over 3. All three of my ratios are equal, so all of my sides are proportional. I have 3 pairs of sides proportional, so we say these are similar by SSS similarity. You have to say SSS similarity, so I know that we're proving similar triangles, not congruent triangles. Okay, and then it says write a similarity statement. Well, the triangle on the left, I'm going to call WXZ. Okay, so WXZ, it means I went longest side, shortest side, middle side. So I have to do the same thing. Longest side, shortest side, middle side. So X, Y, Z. That's the similarity statement. So I know I didn't give us a whole lot of room, but I'm going to erase this so I can show us one other thing that I think is very interesting. Okay, so one triangle that we neglected to talk about is the big triangle. The big triangle has sides of 20, 15, and then this side, this 16 plus 9, which is 25. Well, this big triangle is also similar to the little two triangles. Let's check it with triangle 1. 20 is the middle side. That's going to go with 16, the middle side on triangle 1. 15 is the smallest side. That's going to go with 12, the smallest side on triangle 1. 25 is the biggest side. That's going to go with 20, the biggest side of triangle 1. First ratio, 20 over 6. If I divide both by 4, I get 5 over 4. And then the next one, if I divide them both by 3, I get 5 over 4. And then again, 5 over 4. So the big triangle is also similar to triangle 1. By the same reasoning, the big triangle is similar to triangle 2. So really, there's 3 similar triangles here. I think that's a little interesting. And we're going to be using that fact more next chapter. Now, if you will look down, you have 2 examples to try on your own, please. Pause the video and try both on your own. Come back only after you have completed both examples, please. Okay, let's see how we did. Initially, this first example looks like we might be using SAS. I have congruent angles, both right angles, and I have 2 pairs of sides. Okay, first check. Is this A the included angle? Is it the angle holding together the 2 sides? Yes, it is. I forgot to say they're 90-degree angles, which is why they're congruent. So yes, I have the included angles. Now I have to check if my sides are proportional. My first triangle has sides of 24 and 28. Now 24 is the smallest angle, so that's going to go with 18. The smallest side. So that's going to go with 18, the smaller side on the second triangle. 28 is the larger side, so that's going to go with 21, the larger side. And now let's simplify. 24 over 18, if I divide both by 6, I'm going to get 4 thirds. 28 over 21, if I divide both by 7, I get 4 thirds. These are equal, so my sides are proportional. So yes, my triangles are similar. I can say triangle SRT is similar to P and Q by SAS similarity. And now let's look at the next example. Okay, this time all I have are sides. So AA is not an option, SAS is not an option, so my only possibility is maybe that I'm using SSS. So I need to check, are all 3 pairs of corresponding sides proportional? Well, my first triangle has sides of 12, 15, and 6. Second triangle, 6 is the smallest side, so that's going to go with 6. 10 is the biggest side, so that'll go with 15, the biggest side. And then 8 is the middle side. Right away, I should be able to tell that these are not going to be equal. 6 over 6 is 1. 12 over 8 and 15 over 10 are definitely not 1. In fact, this simplifies to be, if I divide both by 4, 3 halves, and then 3 halves again, which does not equal 1. So these are not similar. Okay, so you have to make sure that you check the proportions. It is very tempting to just look at the triangles and say, I have 3 pairs of sides, the triangles must be similar by SSS. That's not always the case though. You have to have 3 pairs of corresponding sides that are proportional, so you have to make sure that you check the proportions. Okay, flip the page please. Okay, so you're also going to see something like this, where it gives you 3 triangles, and it says which of the following triangles are similar. So you have 2 triangles that are similar. So we have to check which triangles are similar. Well, it looks initially like I'm using SSS. I don't have any angles, so it can't be AA and it can't be SAS. This is my only option. First, I'm going to check triangle ABC with triangle DEF. Triangle ABC has sides of 8, 12, and 16. 8 is the smallest side. The smallest side on DEF is going to be 6. 12 is the middle side. The middle side on DEF is 9. And then the biggest side is 12. Okay, 8 over 6 simplifies to be 4/3. 12 over 9 is also 4/3. 16 over 12 is also 4/3. So these triangles are similar by SSS. Just to make sure we're right, let's check the third triangle. So this time let's do ABC with JHG. Again, ABC has sides of 8, 12, and 16. Okay, the smallest side is 8. The middle side is 10, and the largest side is 16. 8 over 8 is 1. 12 over 10, if I divide both by 2, becomes 6/5. 16 over 16 is 1. These are not similar. So I know that the first 2 triangles are similar, so I'm going to write a similarity statement. Please make sure that we're going to use correct notation. So triangle ABC is similar to, okay, when I do triangle ABC, I go small side, middle side, large side. So I need to go small, middle, large. So that's going to be triangle DEF, and they're similar by SSS similarity. You have to make sure that it's SSS similarity, because we're not proving triangles congruent. Okay, we have 2 more examples. So this example says find the values of x and y that makes triangle PHS similar to triangle GEO. First thing is I'm going to mark the angles that correspond. So P is going to correspond to G. So P corresponds to G. H corresponds to E. And then S corresponds to O. Okay, the reason I did this is because we noticed that our triangles are not in the same order. So that's going to throw off our proportions a little bit. My statement of proportionality then is PH goes with GE. That's because PH is first and second, GE is first and second. Then I have HS, second and third, goes with EO, second and third. And then I have PS, goes with GO. And now let's fill it in with what we know. PH is 4, GE is 12, HS is 8, EO is 2 multiplied by y plus 2, PS is x minus 1, and then GO is 18. Okay, well notice we have 2 unknowns. We have the x unknown and we have the y unknown. So I'm going to need 2 equations, one to solve for x and one to solve for y. This is something that we have done before. So pause the video right now and do this one on your own, please. You should have had enough time to try this one on your own. You should have gotten x equals 7 and y equals 10. If you did not, you need to go back and fix your mistakes. I am not showing you the work because we have done examples like this in class. Okay, and then we have the last example, which is very similar. It says find the values of x that make ABC similar to triangle DEF. Okay, so angle A goes with D, angle B goes with E, and angle C goes with angle F. This time, our triangles match up. Okay, this example you are doing on your own. You need to set up a statement of proportionality, like we did above. You need to fill it in, and then you need to solve for x and y. When you come to class tomorrow, I'm going to make sure that both of these examples are fully completed with work and the correct answers. Good luck.